So we are going to start vectors. So what is vectors? Vectors are the physical quantities which have magnitude plus directions. Okay, so we can write vector quantity. What is vector quantity? Physical quantities which have physical quantities which have magnitude as well as direction. Okay, physical quantities which have magnitude as well as direction are called vector quantities. Okay, example example of the physical quantities will be displacement, after that velocity. What is the formula of velocity? Displacement divided by time. After that force and etc. etc. Like many more. Force is what? Mass into acceleration. Okay, force equals to mass into acceleration. Acceleration is also a vector quantity. Mass is scalar. Scalar into vector equals to vector. Okay, so vector quantities are done. So how we represent vectors? We can say representation of vector. Representation of vector. So we represent vectors with arrow. We represent uh, we represent vectors with arrow. How it looks? It looks like this. Okay, this is arrow. This point is called head, and this point is called tail. Okay, tail and head. Vector have tail and head, both things. Okay, some ways to write. Suppose OA vector. OA, after that upper side vector sign. Vector sign means arrow sign. So it is OA vector. Or force F vector. Force F vector. Displacement S vector. Huh? We can write comma. Ways to write. Ways to write. Or velocity. Velocity is V vector. Okay. So whatever we want to specify with the vector, just write the symbol. After that, just write the thing. After that, make the arrow sign. That will become vector. Okay. With the head, which the head of the vector is specifically says this is the direction of the vector. Okay, if I say like vector about direction, so it means direction of the vector is upper side, means in the xy plane upper side represents y-axis. So suppose this is our a vector which is saying upper direction, it means this is saying y-axis direction. What is direction? Y-axis direction. Same way we have x-axis also. This is x-axis, this is y-axis, x-axis and y-axis. So x-axis is horizontal line, y-axis is the vertical line. So if x-axis is there, so how x-axis vector will be there? If I make like this, so this specifically says this is the x-axis direction. X-axis direction. Okay. So vector we represent with the arrow sign. That is clear. Now we have some types of vectors. Some types of vector. Types of vector. One is polar vector, axial vector, negative vector, like vector, unlike vector, co-initial vector, coplanar vector. These things we will see now. Okay. So polar vector. First one is polar vector. What is polar vectors? Polar vectors have initial point and final point. They are called real vector. So we will write this thing. And if we mirror the polar vectors, they will not change their direction. So polar vectors are real vector having initial and final position. Initial and final position. If we mirror them, or we do inversion of the vector, they will not change their direction. They will not change their direction. So we'll see by example how this thing happen. So what we can do, this is our y-axis, this is our x-axis, minus x-axis, minus y-axis. Okay, same way here also y-axis. But if it is mirror, y-axis mirroring will be y-axis only, but x-axis will change. So what will happen? In this way, it will come according to mirror. That point will come near to mirror, so it will become x, and that later point will become minus x. So in the first position here we have x-axis. So here we have minus x-axis. Here we have minus x-axis. Here we have positive x-axis. Okay. So these things need. This is just for the understanding purpose. So if we make one vector here, suppose it is vector A. So when you mirror it, it will come here like this. So in the mirror, direction is the same towards the y-axis. Here the direction of the vector A is upside, means y-axis direction. So when we mirror it, direction does not change. Now we will see axial vector. In the axial vector, when we will mirror, the direction will change. We will see how. So second thing is axial vector. So what we have written in the polar vector, real vectors having initial and final position. If we mirror them, or we do inversion of vector, they will not change their direction. So in this, these are called pseudo vector. Okay, pseudo vector, and if we mirror them, the direction will change. So they are called pseudo vector. And if we mirror or do inversion, direction of vector will change. I have an image for this purpose. Okay, so here one electric current loop is there, means wire is there and current is there. Okay, so if current is there, then magnetic will be there. What will suppose direction of the magnetic field we will give with our right hand thumb rule. Okay, it means if the direction of the current is towards the finger, then the direction of magnetic field will be towards the right hand thumb. So if current is flowing in this way, then direction of the magnetic field will be towards the thumb. So put hand towards the direction of the current, then see direction of the in the first case, this is our first case. Okay, in the first case, put the finger direction towards the current direction. Okay, then see the direction of the thumb is upside, means direction of the magnetic field is up direction, means y axis we can say. But when we mirror, the direction of the current is showing this direction, means when we will show this way, the direction of the current is going now in this way. Initial way it was like this, initial way it was like this, now it is like this way. So it is going in this way, means direction of the thumb is towards the downward. So initial case direction was upper side, now direction is downward. So when we do inversion or when we do mirroring to such cases, so these vectors are called axial vector, because they, when we do inversion or when we do mirroring, they will change their direction. Here magnetic field, here B is what? Magnetic field. So B is our magnetic field. So so when we do inversion in the current loop, the direction of the magnetic field is changing. That's why the magnetic field vector is what we can say, axial vector. Same way, other example of the axial vector is what? Angular momentum. Or we can say angular velocity. So these are the examples of our axial vector. Now we will move towards the one is like vector. This is our third point. Axial vector was second. What is, so now we will discuss about the like vector. Like vectors means if the direction is the parallel towards the if two or three vectors are there, and if their direction is same, then they are called like vectors. So if vectors having same physical quantity have same direction, or they are parallel to each other, then they are called like vector. Okay, so what is the example? My example will be, suppose this is vector A and this is vector B. Okay, so vector A and vector B, vector A and vector B are like vectors. Okay, magnitude can be different. So if we make a small vector, its magnitude is small. If we make larger vector, then its magnitude will be more. So compare to each other. Okay, suppose this is this much vector and one is this much vector. Suppose this is vector C and this is vector D, but they are not equal in the magnitude, but their direction is same. So they are, if direction is same, then they are called like vectors. So vector C and vector D are like vector. So if direction is opposite, suppose if direction is opposite, then what is that? Then that is called unlike vector. Okay. Our fourth point, unlike vectors. If vectors having anti-parallel direction, anti-parallel direction, then they are called unlike vectors. If vectors having anti-parallel direction, then they are called unlike vectors. Okay. So example, we can say examples. Suppose this is our vector vector m, and just opposite direction. This is vector m. So vector m and vector n are unlike vector are unlike vector. The main thing here is they can have different magnitude. Like one vector can be big, one vector is small. They can be same also, same magnitude. But one more vector comes negative vector. In the negative vector, their direction will be opposite. Okay, direction will be anti-parallel or opposite, but their magnitude will be same. Okay, their magnitude here one can be like in the unlike vector, one can be smaller, one can be big. Okay, but their direction is anti-parallel. They are up in opposite directions. So they are unlike vectors. But when next we will see negative vector. In the negative vector, their direction will be opposite. Okay, but their magnitude will be same. Okay, so here we can say vector f, and here h, vector f and vector h. So what we can say, vector f and vector h are unlike vector. Vector f and vector are vector f and vector h is unlike vector. So now we will see negative vector. Page point 4, fifth point. Negative vector if two vectors having same physical quantity, having same physical quantity and equal magnitude, but opposite direction, then one vector will be called negative vector of the other vector. Then one vector will be negative vector of another vector. Then one vector will be negative vector of other vector. So we can see how. Suppose this is our one vector, vector A. One we have same magnitude, but direction is opposite. Vector B. So the both vectors have same magnitude, but their direction is opposite. So vector A is the negative vector of vector B, and vector B is the negative vector of the vector A. So what we can write? Vector A is the equals to negative vector of vector B, and what we can write, vector B is the negative vector of vector A. Understand? So both can be equal. Suppose what it mean by negative minus vector B? Minus vector B means whatever the vector B, just reverse the direction. So if just vector B have direction this way, we reverse the minus vector will be this type direction. So this direction vector B and negative. This is the negative vector of the B. So see, vector B and vector A, negative vector B and A vector, they have the same direction now, same magnitude. So vector A equals to minus vector B. Same way we can write for the vector A also. So negative vector is clear. After that comes co-initial vector. Sixth point. Point number 6. Co-initial vector. Co-initial vector. Co-initial vector says if vectors having same initial point, then those vectors are called co-initial vector. Vectors having same initial point. Vectors having same initial point or same initial position. Vectors having same initial position are called co-initial vector. We will take example. Suppose from the origin, this is a point O, which is represented by 0, 0, 0. If three axes are there, so we can make one more axis. We have three axes in the 3D. One is x-axis, y-axis, and z-axis. Minus z, minus x, minus y. Okay, three axes. Suppose from one point we have so many vectors from our origin. Okay, so suppose this is vector A, vector B, vector C, vector D. Okay, then vector A, B, C, D are called co-initial vector. Why? Because they have same tail. Vector we have head and tail. Suppose this is our vector, this is our head of the vector, this is tail of the vector. If all vectors have same tail, same position for the tail, then those vectors are called co-initial vector. We can take other example also. Suppose from here, this vector is vector M vector, this vector vector N, this vector is vector P. This so vector N and vector N comma vector M comma vector P are co-initial vector. Co-initial vector. Same way, vector A, vector B, vector C, vector D. Vector A comma vector B comma vector C comma vector D are co-initial vector. Are co-initial vector. We can see now. Vector N and P are co-initial vector. Why? Because they have same tail point, or they have the same initial, same starting point. They all started from the that point. Suppose this point is Q point, so they all started from the Q point. Okay, so they have co-initial point, means they have initial position Q. Everyone have initial position Q. And in the A, B, C, D, they all started from the point. Suppose O. O is the origin. Already I have written there. Okay. O is the origin. So O is what? Origin. Origin. O is here. In the graph, O is there. So A, B, C, D have the starting position O, origin. But N, M, P have the starting position Q. That's why they are, if their vectors having same initial position are called co-initial vector. Same way we have coplanar vector. What is the coplanar vector? If the vectors are in the same plane, if the vectors are in the same plane, so we know we have three type of axes. What we have? X-axis, Y-axis, Z-axis. With the help of two axes, we can make one plane. Suppose if we want to make one plane, we take in x-axis, y-axis. Then is the xy plane. Suppose out of three, we can take any two. Y-axis, z-axis. We can take x-axis, z-axis. Same way we can make yz also. Here y and z, we can make zy. Xy is there, we can make yx also. So this is what plane? Xy plane. Xy plane. This is what? Yz plane. This is yz plane. This is xz plane. This is zx plane. Zx plane. Okay. So with the help of x-axis, y-axis, z-axis, we can make planes. Okay. Now if vectors are there, okay, but all vectors are in the same plane, then those vectors are called coplanar vectors. So let's start here. Which point it is? Seventh point. Coplanar vector. Coplanar vector. Coplanar. So what we can write? Vectors having same plane are called coplanar vector. Vectors vectors having same plane are called coplanar vector. Example. Suppose this is our y-axis, this is our x-axis. Why I make arrow in the last? Because it can be extended. This x-axis can be extended. This is the 0, 0 equals 2 points x and y. First point we will write here is x point. After that we write y point. Okay. So suppose one vector is here, vector A, one vector here, vector B, one vector here, vector C. So all vectors are in the xy plane only. So vector A, comma vector B, comma vector C are coplanar coplanar vector. Vector A, vector B, vector C. Vector A, vector B, vector C are coplanar vector because they are in the same plane. What is the plane? Yx or xy plane. Okay. So till this in this video. Next video we'll see representation of the vector I cap. So I will give some information. So here the x-axis we have y-axis. Okay. If we move on the x-axis, okay, then the direction of moving on the x-axis will be given by I cap. So x-axis direction will be given by I cap, y-axis direction will be given by j cap, and z-axis direction will be given by k cap. Cap, you know how we make cap? Cap is like this. Okay, cap is like this. Okay, so this is the convention we have to follow. If we move in the x-axis, we will give I cap direction. If we move in the negative x-axis, we will give minus I cap direction. If we move in the y-axis direction, we will give j cap direction. If we move in the negative y-axis direction, we will give minus j cap direction. If we go in the positive z-axis direction, we will give k cap direction. If we go in the negative z-axis direction, we will give minus k cap direction. Okay, we can write also. If we go in the minus x-axis, it means direction is minus I cap. If we go in the minus y direction, it will be minus j cap. If we go in the minus z-axis direction, it will be given by the minus k cap. Okay, minus k cap, I j k cap. So this we will discuss in the next video, full detail. Okay.